Assalamualaikum. We will talk about wavelength division multiplexing or WDM. First, we will intro what is a WDMs. WDMs is a technology that increases bandwidth by allowing different data streams at different frequency to be sent simultaneously over single optical fiber network.
Okay, next let's go to WDM, optimize the use of optic fiber. WDM is technology that enables the simultaneous transmission of multiple data streams over a single fiber optic using different wavelength of light. And next, WDM increase the capacity of the fiber without requiring additional physical fibers, resulting in cost saving and improved network efficiency. WDM also technology has two main types, which is coarse WDM and also dense WDM. And it's critical for building high capacity, cost effective, and reliable fiber optic networks that meet the growing demands of high bandwidth application.
Let's take a look at its illustrations. Uh, WDM system is consists of four elements. First is a transceiver transmitter data as lights. Second is a WDM multiplexer optimizes the use of fiber characteristics. And next is a patch cords. Is connecting this transceiver and the multiplexing. And lastly is dark fiber, created for WDM solutions. That you see is only one line.
Multiplexers optimizing the use of fiber channels. Role of multiplexers: gather data streams for simultaneous transport over a single fiber. At the end destination, the data streams are separated into different channels. Then, evolution of WDMs. Early system two bidirectional channels over a pair of fibers. Current system up to 80 channels on a single fiber. Type of multiplexers: 1. Terminal multiplexers, position at network endpoint to create point-to-point connection between sites. Second is optical at drop multiplexers (OADM), used in intermediate sites to extract specific wavelength while bypassing unnecessary traffic. Network versatility: terminal multiplexers for direct site connection, OAMs for creating flexible range distribution and access network.
Assalamualaikum warahmatullahi wabarakatuh and hello, my name is Mohammed Firdaus and I will present about evolution WDM. As we can see, I have put the diagram of the evolution and also the explanation about it. So we can see about the early 90s, saw the second generation of WDM, sometimes called narrowband WDM, in which two of eight channels were used. These channels are now spaced by interval 400 GHz in the 1550 nanometer window. By the mid 1990s, dense WDM system will emerge in 16 to 40 channels and spacing from 100 to 200 GHz. By the late 1990s, DWDM system had evolved to the point where they were capable of 94 to 160 parallel channels then stood back at 50 or 25 GHz intervals. What I can explain is that the evolution of WDM is important. So there we have many channels to support our daily use of the connection and to support the channels that we have. So the increased number of wavelength accompanies by a decrease in spacing of the wavelength. So this is very important to us in our technology evolutions. So that's all for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh and hello. I will also present about wavelength division multiplexing WDM. We can see the figure shows. I put the figure. You can see the wavelength and the single fiber line. This is how the process happen. And the independence optically formatted information stream each transmit at the different wavelength combined with optional com- multiplexer and sent over the single fiber line. Each of these streams could be at a different data rate. So every data that will go into the single fiber line and will send to other place. This shows that many data now use the fiber line to send many informations from a person to a person or a computer to a computer because this is the technology we have now. Uh, this is what I can explain. Thank you.
All right. For the use of WDM in telecom network classifications are roughly divided into three categories. The first is the core network. The core network connects major cities with distances over 100 kilometers, and it utilizes DWDM technology or dense wavelength division multiplexing technology. And then the second category is the metro network. It operates within the metropolitan area, typically ranges between 50 to 80 kilometers, and it uses CWDM or coarse wavelength division multiplexing technology. And then the third and the final category is the access network. Typically, it does not use the WDM technology, and it requires the lower transmission capacity compared to the core and metro network. So and here we have the graph that shows the basic structure of WDM in telecom network. Okay, so for the next part, which is the WDM technology for datacom. There are a couple of challenges that are faced for datacom network, or another name, data centers, especially high-speed data centers, which is the power consumption and space issues. For telecom technology, it uses too much power for large data center. So meaning that the larger the data center gets, the more power it consumes and also more space it requires. So WDM technology helps by being efficient in both power consumption and space requirement. For example, the 100 gig Ethernet transceivers, it is used in data centers with 4 wavelength WDM in the O band, and it minimizes fiber dispersion and increases dispersion tolerance. For wavelength options in the O band, there are two types of it, the CWDM4 and also LAN WDM. CWDM4 uses standard telecom optics, whereas the LAN WDM has tightly spaced wavelength for longer transmission, typically over 10 kilometers, without the dispersion issues. For the graph at side here, you can see it shows the chromatic dispersion against wavelength for the CWDM4 and also the LAN WDM.
Okay, so next is WDM technology for telecom. So first is dense WDM, which is we call DWDM. In order to transmit optical signals over a long distance, which is more than 100 kilometers, optical fiber amplifiers are needed to compensate the loss of an optical fiber. As the gain bandwidth of an optical fiber amplifier is rather limited, a tight wavelength spacing is needed to put a large number of channels into the gain bandwidth. And the dense of this DWDM technology has been developed for a long distance transmission system fully utilized by the gain bandwidth of erbium doped fiber amplifier, which is EDFA. And this EDFA has optical gain in the C band and the L band, which is we can see in the figure 2. Okay, so the second technology for telecom is COS-WDM. The need tight channel spacing in the DWDM technology mainly arise from the relatively narrow gain bandwidth of EDFA compared to the entire optical telecommunication bands. And on the other hand, if the transmission distance is less than 100 kilometers and no amplifiers are needed, a wider channel spacing can be an option. And a wider channel spacing allows the use of inexpensive components such as when uncooled transmitter laser diode LD with a large wavelength variation, and second is when mux and demux with a relaxed channel spacing.